In this lecture, we'll delve into the practical utility of Python's filter function in extracting information of interest from iterables. Let's first understand what the filter function is. The filter function in Python is a built-in utility that sifts through an iterable, like a list or a tuple, and extracts elements that meet a specific criterion. This criterion is defined by a function that returns either true or false for each element in the iterable. The syntax of the filter function is as follows. You have filter, followed by the first argument being the function to pass, and the second argument being the iterable itself. The function here refers to a function that tests each element in the iterable for a specific condition. An iterable refers to the sequence, such as a list or a tuple, which is the data to be filtered. Let's run through some practical applications of the filter function, starting with our example of streaming log processing. In this run, the context could be, for instance, filtering out logs of a specific severity level, where the application of filter could be to define a function that checks the severity level recorded in each log entry. In the realm of genome pattern recognition, the context could be, for instance, identifying specific genetic patterns, where the application of filter could be to extract sequences that match a predefined genetic pattern. And finally, in the realm of stock price anomaly detection, the context could be, for instance, detecting anomalies in stock prices, and the application of filter here could be to isolate stock prices that deviate significantly from expected patterns, let's say. It's important to note certain common pitfalls with the filter function and how to avoid them. Firstly, it's essential to understand that filter returns an iterator and not a list. To get a list, you need to explicitly convert it using the list function. The next thing to note is that a filter object can only be iterated over once. To reuse the filtered data, you should store it in a list first. And finally, the function passed to filter must return a Boolean value. If it doesn't, the filter function may not work as expected. There are two main advantages to using the filter function, one being code efficiency, in that instead of writing loops to filter data, you can use the filter function to achieve the same with less code. And in terms of readability, filter makes the intention of your code a lot more clearer, hence enhancing the readability of your code. In this lecture so far, you've learned that the filter function presents an efficient and readable way to write code that extracts specific elements from an iterable in Python. Let's now get into the hands-on coding session to see the filter function in practice.